Okay, our next problem, we're going to add four vectors. So let's consider that we have a dog, and the dog is out running around. And so the dog walks a distance of 41 feet at an angle of 25 degrees north of east. So this is going to be 41 feet. Then the dog turns and walks 27 feet. And the angle is going to be 33 degrees to the west of north. So this angle down here was 25 degrees north from east. This angle is 33 degrees eastward from north. Then the dog turns and walks a distance here of 33 feet. And this is at an angle that is 28 degrees north of west. Then the dog turns and walks at an angle of here, and this angle right here is 40 degrees and is an angle of 40 degrees from due south. Okay, so it's 40 degrees west of due south. Okay, so now what happens is at that point the dog here hears his owner calling and needs to run back. So we need to find right here what's the actual displacement of the dog. Okay, so this will be vector A, vector B, vector C, vector D, and that's the resultant. Now let's even add one extra bit of information here. Let's say that the dog does vector A in 25 seconds, does vector B in 13 seconds, does vector C in 18 seconds, and then does vector D in 15 seconds. So I'll get back to these times later. Okay, but that's the time it took to do each one of those. Okay, and so what you might want to do is write all this down and draw on a piece of paper to keep track of it as we go through the next slides here. Okay, so we've got to add these four vectors. So we want to add the resultant vector is going to be vector A plus B plus C plus D. Okay, so I want to find the resultant vector. If I get the resultant vector, then I will be able to next, after I get the resultant vector, then I can go forth and figure out how the dog gets back. So then we find the return vector. Okay, so first of all, we need to find how to add those four vectors. Well, we know the triangle formula doesn't work, so we need to find the vector components. So remember, vector A was 25 degrees north of east, 41 feet. Okay, so that means that vector A is going to be 41 feet cosine 25 degrees I plus 41 feet sine 25 degrees J. So vector A is going to be 37.2 feet I plus 17.3 feet J. Okay, so that gives me vector A. Next, I want to find vector B. Now, vector B was a little bit different. Vector B, I told you, was 27 feet, but I gave the angle as 33 degrees from north. Okay, so if I look at that, okay, then vector B is going to be 27 feet sine 33 degrees I plus 27 feet cosine 33 degrees J. And so this is going to be equal to 14.7 feet I plus 22.6 feet J. Now, at this point, let me point out something here. What I did was I measured the angle relative to north. So sine is the opposite side of that triangle. So the x part is sine in this case because I did not measure relative to the x-axis. Students inevitably make a mistake by always assuming that y is sine and x is cosine. Really, what you need to do is look at how things are measured. The opposite side of the angle is the sine, the adjacent side is the cosine. This is how you should be thinking of it, not x is cosine and y is sine, because that's only a special case, and you don't want to be trapped by special case. Frequently, when you're given a vector or given an angle, you're not always measuring relative to the x-axis, you're measuring relative to the most convenient axis. In that case, it is your responsibility to look at the vector and say, oh, wait, what is the x and what is the y? Okay. So, vector C. Vector C was in this direction. Okay, so we had 33 feet, and the angle was 28 degrees north of west. So, for vector C, then this is a minus 33 feet cosine 28 degrees I plus 33 feet sine 28 degrees J. The minus sign comes in here because if I say to the right is positive, then going left is negative. So this is minus 29.1 feet I plus 15.5 feet J. Okay, now vector D. Vector D was like this, so that was vector D, and that was 25 feet, and this was 40 degrees west of south. So for vector D, it's minus, the opposite of the angle is the sine. So minus 25 feet sine 40 degrees I, because it's going to the left, it's going down, so that's a negative for the y. So minus 25 feet cosine 40 degrees J. So for the vector D, this is minus 16.1 feet I and minus 16.1 feet J. Okay, well actually I'm not sure that's right. Okay, so, all right, so 25. Okay. Yeah, actually there's a typo. That should be 19.1 feet right there. Okay, so that's 19.1 feet. Okay. So, that means that we're now ready to find the total. So for the total, then the result is going to be A plus B plus C plus D. So what you would do is you'd add up all of the I components, add up all of the J components, and so what you'd have is 6.7 feet I and 43.3 feet J. So this would be your resultant vector right there. And then all you'd have to do is next you'd have to figure out what is the magnitude and direction of that. And so for magnitude, then what you would do is you would find the Pythagorean theorem. So R would be square root of 6.7 feet squared plus 43.3 feet squared. Okay, and so the magnitude of that would be just 6.7 plus 43. Okay, so that would be 43.8 feet. Okay, so you're going to have 43.8 feet. Okay, and then to find the direction, then you'd look at it and say, well, the direction is this goes over 6.7 feet, it goes up 43 feet. So if I wanted that angle right there, then that would be the arctangent of 43.3 divided by 6.7. And so that's going to be, the angle is going to be the arctangent of 43.3 feet divided by 6.7 feet. So the angle is 81.2 degrees. Okay, so 81.2 degrees. Okay. Well, that's, would you write that? You would write that as 43.8 feet at an angle of 81 degrees north of east. Okay, so it's like this, so there's my angle theta. Another way of writing it, though, would be to give the angle phi. And so that would be 43.8 feet at an angle of 8.8 degrees east of north, or clockwise from north. That's the compass heading right there. So both of these say exactly the same thing. You know, I don't really care which way you do it if you were doing this on a test, because you could do this both ways, and I would not in any way care unless I told you, you know, I needed it one way or the other. Okay, so now the next question I want to ask about this same problem, okay, is what is the return vector? So this is the vector that the resultant vector, and I say, but the dog wants to come back home. So the dog wants to do that. So it's going to be exactly opposite. So the return vector is going to be equal to opposite the result vector. Okay. And so, for the dog to go home, then the result vector is from the origin, beginning to the end. I want to go from the end to the back. So I don't know what we'd call this. I don't know, H vector for home maybe. Okay. And so to get the H vector, well, it's the same magnitude. It's still going to be 43.8 feet, but instead of being 8.8 degrees east of north, now it's going to be at an angle of 8.8 degrees west of south. Okay, and so that would be your home vector right here. Or you could have given that vector right there. Okay, and so you could have said that it's 43.8 feet at an angle of 81.2 degrees south of west. That would be the same thing. Okay, you could have given the vector from north this way, you could have given the vector that angle. It doesn't really matter, you just have to be consistent with how you do it. Okay, had one final question here about this problem, and I'll save that for the very next video.